It's not all the time that we are going to arrange our objects in a linear fashion. Sometimes we want to arrange them in a circular manner. For example, Abby has to arrange for guests A, B, C, and D around a circular table. So let's say this is where, oops, sorry. There you go. This is where A is, B is, C is, and D is. So what are the other possible arrangements and how many would there be? So if we are going to rearrange, oops, sorry. Let's reselect our object so we can easily rotate that. Let's rotate it like this. Is it a different arrangement or a same arrangement? Now, if you're thinking it's a different arrangement, most probably because you notice the fact that in this position, where I drew a green circle, there's a different occupant. However, if you are still looking at the fact that you start counting from guest A, then the arrangement did not actually change. It's just the same. We're just looking at it in a different way. And that notion of where to start in a circular arrangement is important because that is where we start counting what are the different possible arrangements in our circular arrangement. And when we do arrange objects in a circular manner, we call it circular permutation. So the number of circular permutations of n objects is given by n factorial over n or n minus 1 factorial. This minus 1 or this n is our starting point. So this is the point wherein we know that there are actually other changes because that point stays the same. Or at least we know that since that point in the circle is not the one that is changing around, that is where we start looking at. The other changes are the ones considered. For example, if we go back to our example of the arrangement of Abby, there you go. If we're just going to look at this position, that means if this changes to a different arrangement, say this will now be C, D, A, and B, since we know that this changed to C, that's a different arrangement already. That is that one that we remove from the formula of a circular permutation. So let's have some examples. If we are asked to find the number of circular permutations of 7 dancers, all we need to do is find 7 minus 1 factorial, which is 6 factorial, which is equal to 720. If you want to find the number of circular permutations of 8 children, then all we need to do is find 8 minus 1 factorial, which is 7 factorial, which is equal to 5,440 ways of arranging our 8 children into a circular formation. That is circular permutation.